Okay, so welcome back to the final part, and as promised in the previous video, what we're going to do is prove that this relationship here is true. So, what it says is that A union B is a subset of this set here union with B. Okay, so again, we just break it up into small parts, and we will tackle the problem in bite-sized chunks. Okay, let's do it. Do it. Okay, so we need to prove that an element of this is, if an element in here exists, it's going to exist in this set here. So remember, this is an OR. So we have X belongs to A or B. But then we have to consider two cases. We have to consider the case where X belongs to A, or X belongs to B. Now, for this second case, right, this is 1 and 2. This second case, it's immediately obvious, because if X is in B, right, it means it's going to be in this set because it's going to be in B or some other set. So of course it's in B. So that's done. Now the trickier case is A. So we have to prove that if we start with this, it's somehow in this set. Okay, so before we proceed, we're going to prove a result. So we're going to more transform the second set. So the second set is this thing here, all right? Union. Actually, for now, let's just forget about that. So we're going to transform this thing here into something, so this set here. So forget about the union. We're just going to play with this, right? Okay. Now let's do some of those tricks we used in the previous video. So this is equal to. Now I know I'm using an equality here, and you'd have to do the whole equality thing. So like a whole nother proof. But if you just draw those two circles I always draw, you can see that those regions overlap, and you can just infer, yeah, they're definitely equal. They're definitely equal. Because we have to save some time. But you can say, okay, this is the same thing as the intersection of that, but it's the complement. Okay. Now the great thing about the complement operation is that you can distribute it inside here and inside here. Yep, you can do that. And then you swap kind of the direction of this one when you distribute it inside. And you can also do the reverse, so you can take it out and then you have to swap the operation here. So let me just do it so you actually know what's happening. So we have this thing here, that's just copy and paste. And then we have to do this. So it's going to be A complement union with B complement, right? So that's how you just distribute a complement. And you can also, I don't want to do it because the video will get too long, but you just try to reason why this thing here is equal to this thing. And then the way you do it is you just draw two circles and then shade in like which region is which, and then you'll find that both sets are equal. Anyway, moving on, we can distribute this intersect here. So it's just like expanding the brackets. So A intersect A complement union with A. So this is hard stuff. You have to do it a few times before you understand what's going on, I guess. Okay. And again, you can draw the two circles and find like, oh, you can distribute the intersection like that. Yeah. Okay. So the next thing to do is realize that this is just the empty set, right? Because remember that you take a set and you intersect it with its complement, so everything that's not A, that's just going to be nothing, right? Just by definition, almost. I know exactly. By definition, sorry. I'll get rid of that and draw a proper empty set. Can I get rid of it? Oh, okay, whatever. Saved them. So that's what an empty set looks like. And then we've just got this one left here. So that's just gonna, because this is empty, it's like saying 0 in the world of sets. So we just say that, right? Okay. Now it's obvious because we turned this thing here into this thing here. So the original set up here, this thing becomes what we turned it into. It was A intersect, sorry, what was it? It was A intersect B complement, correct? Or B. And now it immediately follows, because if A here, if we have an element in A, that means that it has to be in this. It could be in this or this. Well, it's in this, but it's in this specific set here. It's in A and B complement, but it's in A nonetheless. So yeah, it's in here. So we can confirm that X is part of this whole set here. So that's done. So we've proven, and then when we prove that, we've proven this direction here. We then say we have proved that A union B is a subset of A, of whatever this big set is. Now the thing is, in the previous video we proved the opposite direction. So when the subset thing was going in the other direction, and now that we've proved both of these, we can safely say that, going back to the start, that they are equal. Yeah, okay. Anyway, to recap, that was the next question is going to be much easier, and well done for sticking through this video. It's intense. It was intense. I think this is going to be the hardest question in the course. But you've done it, so well done. So just a quick recap. We wanted to prove that this and this set were equal. So what we had to do was prove that this set was a subset of this set, and then we had to prove this set was a subset of this set. And we managed to do that. And we also learnt about how to deal with these operations here. So this one means and intersection, and let me find a or yeah, and this kind of thing means or, right? And when we start with an or, we need to split it up into two cases, and then just logically go through how to prove things. So yeah, and draw pictures as well. Draw pictures. Okay, so that's it. This was a very, very, very hard lesson. Probably, I think the hardest. I shouldn't have put the hardest one at the start, but good job, good job. So next up, we have something a bit more fun. We're gonna do our first video on Python. So you're gonna start learning Python and how to code. So I'm excited to do that, and I hope you're excited as well.